You know, in the tech world, we're all about the next big thing, right? The newest, the fastest, the shiniest. But what if the most incredible breakthrough wasn't a brand new invention at all, but just a really clever upgrade to a piece of tech that's been around for 100 years? Today, we're going to look at how one simple tweak supercharged a classic, making it even better than its modern rivals. Let's dive in.
So let me just ask you this. What if you didn't have to throw out the old to make way for the new? What if you could take something trusted, something that's been working for a century, and with one smart move, make it outperform even the most advanced cutting-edge competitors? Well, that's exactly the wild story we're getting into today.
All right, so to really get what happened here, we need to meet the hero of our story. It's a piece of technology that, for most of us, is working completely invisibly, humming along in the background of our everyday lives. I mean, for nearly a century, 100 years, one type of controller has just completely dominated industrial applications. We're talking everything from massive manufacturing plants to the thermostat in your own home. It's been the undisputed, super reliable champion at keeping all kinds of systems stable and right on track. It's called the PID controller. Now that stands for proportional integral derivative, but don't get bogged down by the name. The easiest way to think about it is like the cruise control in your car. It's pretty simple, right? You set your speed, and the PID is constantly checking, are we going too fast, too slow, and it just taps the gas or the brake to fix the error. For a nice, flat, predictable road, it works perfectly. But here's the thing. Even a champion has a weak spot, a kryptonite, if you will. And for the PID, its kryptonite is the unexpected. So for our cruise control, that's a sudden steep hill that pops up out of nowhere, or a huge gust of wind that hits you sideways. The PID reacts, sure, but it's always a step behind, which leads to these sluggish responses or overshooting the mark. It's fantastic at correcting an error that's already happened, but it has no way to anticipate one. And, well, that weakness, it basically left the door wide open for a new, much more powerful challenger to step into the ring. A controller that was designed from the ground up specifically to handle the unexpected. So this put engineers in a really tough spot. On one hand, you've got the simple, trusted PID that everybody knows how to use. On the other hand, you have these new advanced controllers, like something called ADRC, that's Active Disturbance Rejection Control. These things are incredibly powerful, but man, they were so complex that for a lot of engineers, just implementing one felt like this massive, intimidating barrier. The ADRC is like upgrading your basic cruise control to one that's got GPS and a real-time terrain map. It literally sees the big hill coming and adjusts the engine before you even start to slow down. Awesome, right? The problem was, for many engineers, its internal workings were a total black box. Super intimidating, a nightmare to tune. And get this, you'd have to rip out your entire old system just to put the new one in. So the industry was basically at a standstill. Do you stick with the reliable old-timer, or do you face the headache of this complex new powerhouse? But then, a group of researchers had this absolutely brilliant idea. What if it wasn't a choice between old and new? What if you could just upgrade the old one? And this was the big aha moment. Instead of just accepting this new advanced controller as some mysterious black box, they did something genius. They decided to pop the hood and look inside. And when they did, they found that its super complex internal structure could actually be rearranged and simplified, mathematically, into something, well, something that looked surprisingly familiar. Okay, and this is the absolute kicker. They discovered that this incredibly powerful complex ADRC was mathematically the same as a classic PID controller with a special filter attached to it. This filter basically acts like a smart lookout, estimating what disturbances are coming and then proactively canceling them out before they can even mess with the system. It wasn't some brand new alien technology. It was just a good old PID with a special add-on. They called it the FPIDN paradigm, where that F just stands for that all-important filter. And look at how beautifully simple this made everything. You don't have to rip out the old engine anymore. You just take your existing PID controller, you add this specially designed filter, and you apply a few new tuning rules. And the result? You get all the incredible disturbance-fighting power of the advanced controller without any of the complexity. It's literally like getting a simple software patch for a 100-year-old machine.
Okay, so that all sounds amazing on paper, right? But the real question is, does it actually work in the real world? The researchers knew they had to put this new idea to the test to see how it performed when the rubber really met the road.
So they set up this experiment on a high-precision motor system. You know, the kind of thing you'd find all over industrial settings where accuracy and stability are absolutely critical. They took a standard PID, they applied their new FPID-N upgrade, and then they pitted it against both the original PID and the more complex ADRC to see what would happen.
The results? They were absolutely definitive. The upgraded PID was faster, it reached its target position with less delay, and in a factory, hey, that means more productivity. It was way better at rejecting those sudden disturbances or steep hills. The whole operation was just smoother, which means less wear and tear on really expensive machines. And the best part of all, it did all of this by building on the existing, trusted technology that engineers already knew and loved. And what's so cool about this, and why we're talking about it, is that this is way bigger than just one clever fix for one little controller. This really represents a whole new way of thinking about how technology can move forward.
And this new philosophy is already solving other problems. It turns out that this same approach, using smart filters to modify existing systems, is also great at canceling out all that static or high-frequency noise from sensors that can totally mess up a system's performance. It's another perfect example of upgrading, not just replacing.
I mean, listen to how the researchers themselves put it. Their goal, they said, is to aim at injecting the features of advanced control theories into an existing classic controller rather than merely replacing it with an entirely new one. Just think about what that means. You're saving money, you're not creating a bunch of e-waste, and you're making it way easier to adopt new tech because you're just training people on an upgrade, not a whole new system. It's progress that's sustainable and backwards compatible.
So the big takeaway here is really a new perspective on what innovation looks like. It isn't always about starting from a blank slate. Sometimes the most incredible breakthroughs come from finding the hidden potential in something we thought we already knew inside and out. It really makes you wonder, doesn't it? In a world that's so focused on the next big thing, what other classic, proven technologies are out there, just waiting for the right upgrade to unlock their superpowered potential?